today's video. Why are your pants off?
Standard. And it's going to take us to an activity we're going to do today.
Try again.
Wait, what?
Accidentally dropped the pencil again. Pull down your underwear. Pull down your pants again.
All right. So today I want to wrap up energy and its role it plays with different atoms, which is going to take us to the atomic emission spectra. So I'm going to talk about what a continuous spectra is, and then what's the atomic? How is it different? So we're still copying yellow, so nothing just yet.
All right, hold on.
So a photon of red light, you see there at the top, has a relatively long wavelength, meaning it has a very short frequency and carries less energy
What was it called?
than a photon of blue light up there with a relatively short wavelength. So this information actually gives me a relationship. So putting the two equations together, if I've got a long wavelength and I've got a short frequency, that's going to carry over to the energy. The energy to frequency relationship is a direct one. So if I've got a short wavelength, I have high frequency, I've got high energy, and vice versa. Long wavelengths have low frequency, they have lower energy. So this is showing us the two relationships between those. This is at the either end of the visible light spectrum, red to roughly violet, is going from a longer wavelength to a much shorter wavelength. And that progression happens across the entire spectrum. So let's talk about what an atomic emission spectra is. So the picture you see here is what we call a neon light. It's actually a misnomer, not a correct name, because there's more than neon. So neon lights will consist of any gas from the noble gases, so group 18. So you can have helium, you can have neon, you can have argon, krypton, xenon, radon. Well, how are they different? It's going to be, as you can see, in the colors. So why are the colors different? So the light in a neon sign is produced when we pass electricity through that tube filled with gas. So what happens is we add a bunch of energy to those electrons. They become excited. So when they become excited, they then start to lose energy because they can't stay excited. It doesn't happen. You turn the light off, the color goes away. So what happens is as they return to their original state, they will emit light in different colors to release that energy.
Yeah, just like what? You make no sense on this. Shut up.
So the body of the star is neon, being orange, but the middle part, where the strings would be, is actually krypton. So why are the colors different? We're going to talk about that.
Krypton from Spider-Man. And we're not supposed to throw up gang signs on the street. Look at the close-up quality. Ew. Yeah, why is the close-up quality so good? Let's see the lead. Oh my god, look at this close-up quality. It's actually pretty good. And look at this. See? What the heck?
So these colors we see will tie into the emission spectrum. Now, how is this different than a continuous spectrum?
It's not.
So a continuous white light spectrum has all of the colors. It starts in red and it goes all the way over to violet. So it's the rainbow. Roy G. Biv.
Ooh, Roy G. Biv. Dang.
So we go red, orange, yellow, green, blue, purple, violet. So that will be the progression we take through a continuous spectrum. There's no breaks. It's just going from red all the way to violet.
No breaks, chat. No breaks.
So it has colors at every wavelength. That is a continuous spectrum. That's what you'd see if you look at the sun outside with a special device, or even if you look at fluorescent light in here with a special device. I'm going to show you that device. You would see that continuous spectrum. So how is this different than the atomic emission spectrum? It is tied to the electrons. So individual elements that contain different numbers of electrons will only emit very specific colors of wavelength. Slides.
Stop sighing for attention, bitch boy. You wanna like? You said you want to kiss again? Oh, I need to do my work. You don't copy
So for
those
the elements,
only
this
the
actually
yellow.
provides
It's
a
the
very
same
unique
thing as the board.
set of information, which creates like a fingerprint of that element's expression. Astronomers use this actually to test to see what stars are made of in distant galaxies, distant distant galaxies. So our sun, which is our star, is predominantly hydrogen. It's relatively young in ages for a star. So the spectrum we'll see will reflect that hydrogen within the core and some of the other elements that then progress outwards. In a different galaxy, their star might be going closer to its end of its life, and it is predominantly made up of carbon. So the colors will be different. So they're able to track this and see what stars are actually made of. So the energy of the photon being released corresponds to the different wavelengths or colors of light. So let me show you what I mean.
Mm-hmm.
So at the top is the continuous, unbroken, going from red all the way over to violet. That is a continuous light spectrum. So if you see me look at white light, it's the thing we see on the electromagnetic radiation spectrum. So let's say we look at hydrogen. Hydrogen contains just one single electron. So when that electron is excited, when it starts to lose energy and go back to its ground state, it emits 4 bands of color. That's it. Out of this entire spectrum, we get a orange, a light blue, a dark blue, and almost a purple. That is it. That is hydrogen's fingerprint. You won't see anything else.
Hydrogen is.
The next element, helium, contains 2 electrons. So the spectrum is different. You'll notice there are more bands. They're in different locations because where those electrons are makes a difference in when it becomes excited, what happens. So you've got a red, a yellow, a light blue, medium blue, and dark blue, and that's it. That's helium's fingerprint. So let's look at an element a little bit farther down the table, neon, the next noble gas.
Neon.
Now we have 10 electrons. So the spectrum reflects that. There's more bands of color because more electrons are being excited, and as they fall back into their ground state, they emit these bands of colors. Now you'll see where the black part of the spectrum, no color is being emitted.
I'm on the neon spectrum.
And that is why it's a fingerprint.
My bad.
So, with that, that's in the notes.
Wait.
We're going to do a little activity, which I'm moving around. So, if you take one of these and pass it back.
Bro, how do I live stream and move around? You're excused.
So put your hand on the top. 1 over second. It's just also how you frequency.
I just got stuck. Oh, fuck. Ow. Just jam my finger. Oh, I didn't jam your finger. It's not how you jam your finger. You crushed your finger. You stupid piece of bacon.
Appreciate it.
I appreciate it. Yo, you gave us way too much.
You return the extras, dumbass.
Please put your name on the top. We're going to alter this worksheet. If you get it, I want to talk about.
Wait, can you hold your hand out? Game day, can you hold your hand out? Bro, I need to give these people. Oh, why'd you. Bro, I could have just handed it to her.
Alright.
Stupid. I was gonna give it
On
to
the
her.
front, where it says summarize that first X, we're going to put an X to that box. We're not going to summarize. We're going to put an X through the X. We're also going to
Oh my god.
create on the front. So put an X in that C box as well. We're going to do 4 stations. We're going to do the interpret, the experiment, the navigate, and the challenge. Let me explain where these are at. They're kind of split evenly throughout the room. So you're going to travel through half the room.
It's falling
Station 1 and Station 5 are the same thing. This is the navigate station. So you'll come over here. You're going to read the directions that are in the sleeve. There are 3 different bags of cards. Read the directions. You'll then sort them out. You will then figure out how to complete the statement under the N on the back. Stations 2 and station number 7 is our interpret. So on the front and the bottom, they give you an electromagnetic spectrum, and they want you to answer the 7 questions that are listed there. Station 3 and Station 8, there's nothing there. You're going to use a QR code that I'm going to put up on the screen to scan, and then you will complete the questions under the challenge on the back. The last, Stations 4 and Station 6 are going to be the experiment station.
Yeah.
So you've got the directions on the front with some questions. On the back, do not take out the big papers. You have some examples of the different emission spectra of elements. You're going to take and try to determine what star A, B, and C are composed of.
Okay.
When you finish, please slip the slips of paper back into the sleeve so they're not going all over the place. So I'm going to have you go up to 4 people at a station. I'll keep time on the board about what I want you to work on. And then I'll let you know when to move.
God.
Do not
Yeah, we're
move
failing.
until I tell you to do so. So go ahead and move to one of the 8 stations, please.
Oh, they're coming. There's no more stations. You have to go to another station. There's no more papers.
Miss Brezio, scan your phone. If you're at stations 3 or 8, get your phone. Otherwise,
Can I get mine?
go ahead and get
Oh,
started.
bro, you always want your phone. Like, why you always want your phone?
Okay. Gentlemen, if I see you touching each other, you're being separated. Wait, number 3 is for what?
What am I doing? Touching my butt cheeks.
Is number 3 for I or for
What station is
number
this?
3 is for the challenge?
Yeah, but like, what letter, bro? Bro, this experiment. You know, dragons like music.
Stop spinning on me. Yo.
Spray it, don't see it.
Oh, I got the wrong.
Do we need the safety goggles?
Wait, I'm so confused.
Oh my gosh, bro, let me focus on my
Wait, where do we write this? Right here.
hydrogen.
No.
What does this mean, bro? I don't get it.
He provides
Helium.
Stargates.
And not the spectrums for stars. A, B, and C.
Yeah. Yes, you can't see the whole spectrum too.
You know what happens when you get it's like
Yeah, and then
Find a partner for this activity. Owen, would you not want to be my partner?
oh, will you marry me?
You and your
So when it shows that
Continue.
my God, shut up.
If you start A, B, C out of active matches, it's one thing on your clock. Observe.
I'm actually confused. I'm gonna go
Maybe we can get
instructions, retard. You know how to fucking do it, man.
Oh wait, we have to do check mark for X for G. I know. I remember one video we lined it up like
back it up.
okay, so there's hydrogen and sorry.
Can else be target them?
Oh, we have to look at the lines.
Start. Oh, someone start A. Start A.
Start A has helium, gas helium.